this last topic of module 5, that is pointing vector and quantum theory. So, as you can see, by means of electromagnetic waves, any waves that we have here, the electromagnetic waves that we are considering in this chapter, we use it to transfer energy from the transmitter side to the receiver side through any medium. The medium can be a conductor, a dielectric, or a free space. Okay. Now, as we can see, the unit of E is volt per meter, H is ampere per meter. If I multiply these two, what will I get? Volt per meter into ampere per meter. Volt into ampere is nothing but power, right? That is watt. And meter square. So watt per meter square, that is power by area. That is nothing but power density. Okay, so power by area is power density. So when I take the product of E and H, I get power density P. Okay, which is given by the equation P is equal to E cross H. E also has a direction. Electric field also has a direction, and magnetic field also has direction. So obviously the cross product of these two will give you a dimension which has both magnitude and direction. So your power density has both magnitude and direction. Okay, this is very important to call this as P as pointing vector. Okay, so if they ask you to find pointing vector, then you are supposed to calculate the P value, which is equal to E cross H, right? So this is the pointing vector equation. Now coming to pointing theorem, it states that the net power flowing out of a given volume is equal to the rate of decrease in the energy stored within the volume minus the ohmic power dissipated. It is nothing but law of conservation of energy. How much ever power is coming out of it, the same amount of power is reducing inside the volume also, right? Now say suppose for example, I have 100 electrons inside this. If 50 are coming out, then the same 50 is reduced here. If 50 are coming out, then how much has it reduced inside? By 50 only. Right? Same thing. If you the amount of power that is coming out will be the same as the power that is reduced inside. And along with that, a small amount of power is wasted in the form of ohmic or heat. Okay, it is wasted in the form of heat because of the materials that are there. Okay, so now next thing, aside in the previous video, if you see some problem, I had already mentioned about this equation there, right? You're doing cross product here. Okay, this is cross product. So if I have an intensity which is in x direction, if I have magnetic field intensity which is in y direction, the cross product of these two will give me a result, a total wave which is in z direction. Okay, ax cross ay will be az. Similarly, if I give ay cross az, the final waveform will be in x direction. If I have z cross x, then the actual total wave will be in y direction. Okay, you need to know the cross product property. Unit vector cross product property. Okay. Next thing, the same thing. Now say suppose I have a E which can be written in this format, a wave, electric field wave, which is written as Em cos omega t minus beta z in AX direction. This is magnitude, this is the phase of it. Okay. H can be calculated as Em by Hm is eta, right? So H can be calculated as Em by eta. If I'm considering free space, the eta value is 377 terms. So from using this relation, I can find H value. So the equation for E can be changed to equation of H, which is Hm cos omega t minus beta z. If this is in x direction, I'll assume this is in y direction because in the here you see z is given as the direction of total wave. Okay, so final wave direction is z. E is x, so obviously H will be the remaining, that is y. Okay, and Hm can be calculated as Em by eta naught. So now in this pointing vector or pointing theorem equation, if I substitute E and H values and simplify it, see this Em into Em by eta naught is a constant. It becomes Em square by eta naught. Next you have cos omega t minus beta z, cos omega t minus beta z. So cos square omega t minus beta z. Ax cross product with Ay gives you Az. So this is the equation you get for pointing vector. Okay. And if power density is given and area is given, power can be calculated as power density into area. Remember this, okay? Power density is power by area. So power will be density into area. Okay, one more thing you have to know here is finding out average power density. So for average power density, what you have done is power density equation. If you want average from this, you have to take the average of this equation. That is integrated over one cycle and divided by the period. That's what is done here. So once for one cycle, I have to integrate it from 0 to t and divide by the time period. Average is nothing but you're adding the values of all the values and dividing by number of values, right? So here also I'm going to do integration for addition for all the values and divide by the number, that is total time period for one cycle, that is t. Okay, so this is constant kept outside the integration. Here actually there is a cos square. Okay, in the notes there is a mistake. I have written it as cos. It is actually cos square. So cos square theta can be written as 1 plus cos 2 theta by 2. That is what is done here. And then they split the terms. 1 by 2 and this cos by 2 is split into two parts. And then they've integrated it. So 1 by 2 becomes t by 2 after integration. Cos becomes a sine. And if you know, sine is a sinusoidal signal. Average of a sinusoidal signal is 0 because it has equal positive and negative values. So when I take average, it gets cancelled and the average of a sine will be 0. So you can directly say that this portion is going to give you an answer as 0. You will be having only this much from 0 to t. Okay, so all this is not necessary. So directly from here, you can say this is 0 and directly write the em square by theta, t by 2 in the limit 0 to t. So apply the limit, upper limit minus lower limit, you will get t by 2. And by multiplying, this will get cancelled. And final answer you're going to get for average power is half of em square by theta. And this formula is very important to solve problems. Okay, so half of em square by theta. This is average power. Call this as average power, not density, just average power. Okay. And then after this, I'll directly come to this concept that is finding out instantaneous, average, and complex Poynting vectors. So here, just know these formulas, okay? If I ask you for average complex power, then the formula will be half of the real part of E cross the conjugate of H. When you solve problems, you will know what does H star mean. H star is conjugate. That is, if you have cos of something like this, e power j beta into z, the conjugate will be e power minus j beta z. Wherever you have j term, the sign of the j term should change. That is conjugate. Initially, if you have e power minus j, the conjugate will become plus j. Okay. So this is called average power and this is reactive power. For average power, we take real part. For reactive power, we take imaginary part of this. Okay, and the total instantaneous power is a combination of these two, the addition of these two. So please remember these two formulas, average power and reactive power for problems. Okay, that's it from Poynting vector and Poynting theorem. Just main formulas you need to know. Coming to the problems, the first one, in free space, E is given. They ask you to calculate the total power that is passing through a rectangular area of side 30 millimeter and 15 millimeter in z equal to 0 plane. Assume that Em by Hm is eta naught and eta naught is 125. Free space is given. E value is given. Okay, what you're supposed to find is power. Power is power density into area. Area is a rectangular, so it is 30 mm into 15 mm. That will give you area. So first you have to calculate power density. If you know the power density, you can multiply with area and find out the power. Okay, and for power density, the equation is this. Average power. Average power density will be half of real part of E cross H star. Okay, so E cross H star. E is given in the question. H needs to be calculated first. Okay, so this is E given in the problem. 150 sine omega t minus beta z AX. Okay, if I have to write this in phasor form, it is written as magnitude is as it is 150. Instead of sine, you will be writing it as e power j minus beta z minus omega t. Okay, so here, one second. Instead of pi by 2, just keep it as omega t. We're not given me this pi by 2 here. Keep it as omega t. Okay. One of them, so the direction is going to be positive z direction, so it will be minus j beta z. And omega t is also written as minus j omega t because it is a sine term, right? For sine, you're going to just convert it into polar form. It will become e power j minus beta z minus omega t in ax direction. H will be calculated as 150 by eta. Instead of x, it will be y direction. Okay. And if I want conjugate, the conjugate is going to be wherever you have j, the sign of that j will be changed. So as you can see here you have minus and minus. If I take minus common, it becomes minus j, right? So that becomes plus j. The conjugate is going to become the opposite polarity. Okay, it is also omega t, not that. It is omega t. Okay. So initially for E it is minus beta z minus omega t. Conjugate of that will become plus beta z plus omega t. Then take the cross product of these two. So now you see this is positive, this is negative, so this get cancelled. Both of them will get cancelled. Ax cross Ay is Az, and only you have this much magnitude multiplied. So finally you're going to get the power density as this. And now this power density multiplied by area will give you the power, average power. Okay, so just pause the video and just check the steps again. Simplify it yourself. And go to the next question. This is also similar to the previous question. First, you have to find E cross H, real part of E cross H multiplied by 1 by 2. This is what you have to do to find average power density. Okay, so again here it's given 50 cos omega t minus beta z. And as you can see, whenever you have cos, the omega t value is written as positive. If you have sine, the omega t should also be written as negative. Okay, remember that. So omega t is positive if it is cos, omega t will be negative if it is sine, right? So this, and if I take conjugate of this, the j term will become minus. So omega t becomes minus, beta z becomes plus. That is conjugate. Take the product of cross product of E and this conjugate of H. And after simplification, we will find out the result like this. And this is multiplied by area. Here, they're given circular area of radius 2.5. So if you have a circle, the radius is pi r square. Okay. So you have to use that to find the power. Okay. Similarly, the next question. 800 megahertz plane wave traveling has an average pointing vector. Average pointing vector. So P is already given to you. Okay, average pointing vector or average P is already mentioned 8 milliwatt per meter square. If the medium is lossless with mu r and epsilon r, if it is lossless, it means it's a perfect dielectric with alpha 0. You have to find velocity, wavelength, intrinsic impedance. So these three are calculated as usual with the previous problems of the perfect dielectric equations. Till here there is no change. Now when it comes to the next D part, that is they're asking to find RMS electric field E and RMS magnetic field H, right? That is where this pointing vector average comes into picture. So just now you saw this equation, E average is half of EM square by eta, right? You did that integration and you found out the average power density, right? Half of EM square by eta. So this is given now. Average power is given. Substitute, interchange, simplify, find out EM value. But what is asked is RMS. What you are getting is maximum. So RMS is nothing but EM by root 2. You have learned this in rectifiers also, right? So ERMS will be EM by root 2. And if you want HRMS, we know ERMS by HRMS is equal to eta. So HRMS will be ERMS by eta. So if you do that, we'll be able to find the HRMS value. Okay. So same way, this problem is also supposed to be simplified. Same problem, only the values are different. Again, I've asked you to find out alpha, beta, and all that. Read the question carefully. If it is mentioned perfect dielectric or lossless, then alpha is 0, beta will be given by this equation, d is omega by beta, lambda is 2 pi by beta, eta is root of mu by epsilon. And pointing vector average is given here, 1 watt per meter square. This is a magnitude. There is no direction. That's why I'm using this formula directly. But if direction was given, then you have to go back to this formula. half real part of E cross H star. Okay. If direction is given, use this for average pointing vector. If direction is not given, only magnitude is given, then you can easily use this formula for average pointing vector. Okay. So just interchange. Here they're asking you to find RMS electric field only. So first you find EM, and from EM by root 2 you can get ERMS. Okay. So you can just check the problem once. Pause it and you can which we will class. Okay, the next question. The electric field intensity at a distance of 10 kilometer in free space from a radio station is found to be 22.2 millivolt. E is given, EM is given. Power density is supposed to be calculated. Power density is nothing but here direction is not given, right? All you want is the magnitude. You just have to multiply E and H to get the magnitude of power. So E into H gives you power. So E is given, find out H. Free space, it is mentioned as free space. So H will be E by eta naught. So by doing that, H value can be calculated, and by multiplying E and H, you will get the power value. Okay. This is power density. What you're calculating is power density. And what you want is now total power. So first one was power density, and the second is total power. Power is power density into area. So power density into area. Here they've given you one hint. Assume that the radiation is spherically symmetric. Spherically means the radiation is in the form of a sphere. And for a sphere, the area is 4 pi r square. And r here is this distance 10 kilometer. Okay, so use that and simplify it. Find out the power. Remember the difference. What you calculate here, P is equal to E into H, or P bar is equal to E cross into H bar. This is density, power density. Okay, and power should be calculated as power density into area. What you calculate in these two formulas is power density. Even what you do here, average power is equal to half of EM square by eta. This is also power density. Another formula, average power is equal to 1 by 2 real part of E cross H star. This is also power density. Okay, all these equations will give you power density only. And power should be calculated as power density into area. Area according to the type of material. If it is a rectangle, side into side. If it is a circle, pi r square. If it is a sphere, 4 pi r square. Okay. Last problem. 8 watt per meter square is a Poynting vector of plane wave traveling in free space. What is the average energy density? So Poynting vector, the magnitude is given, so it is P, average P magnitude, which is half of EM square by eta naught. So you need to calculate the average energy, that is nothing but EM value. You just have to calculate EM value. Okay? So just simplify, interchange the terms and simplify it. Rearranging the terms, you will be able to convert the EM. Okay, so with this we've completed the module 5. The most important topics I've covered. I've skipped some one or two concepts in between, which I felt are not that important. But the problems are quite easy in this. Please go through it. Okay. All are formula substitution. So with this we've completed all the 5 modules of your year. Thank you.